Good evening, ladies and gentlemen. Tonight's stream will be a quick stream where we'll be talking about the structure of Unreal with regards to assets and packages, and then some of the reasons I haven't been streaming, mostly due to needing to focus really hard on the code, and then how I've solved some of the importing problems that I've been having. And yeah, I'm successfully importing a texture from Descent into Unreal now, which is a huge step forward. Textures in Descent were coded in a very compressed fashion, so I had to code a decompressor, and the decompressing is done at render time, which means that you actually have to get really deep into the Descent code to actually figure out how the texture is being decompressed. But we got to figure it out, and I'll show you guys that. And then we're going to go into a discussion about organization and how you would want to organize a project like the one we're developing. Because right now it's organized wrong, and now that I've got kind of the basics hammered out, I think it's time to go ahead and reorganize. All right, so okay. So Unreal, as I'm sure most of us are aware, Unreal has all of the individual little pieces of Unreal. Every script, every model, every texture, every material, every level is split up into individual assets. These assets have kind of like a standard header format where they can be filtered and organized in the content browser, but they have different internal formats. So a texture is obviously going to have a different internal format than a model. These assets are grouped into packages, and the packages are it's just literally just an archive of assets, just like a zip kind of assets. And the packages are designed to be loaded at runtime. The assets aren't, right? You can load assets at runtime, but they aren't really designed for that. The idea here is that loading in chunks is faster than loading individually. So what you want to do is create a series of chunks in your world. This might be individual levels. This might be individual sections of levels that you want to load in, and you package all those into individual chunks, and then you load everything in. This also provides some really good mod support because you can have a package that you load in after your existing package and like look at before your existing packages. So for example, if you have a high-res textures mod, you can load in the high-res textures package, which contains a bunch of high-res texture assets. And you look at your high-res textures package first, and if it's there, you don't go looking elsewhere. You just go on to the next thing. So that seems like a pretty simple and straightforward system until you start getting into doing things like loading or importing assets in real time. Remember how I said assets aren't really designed to be loaded at real time, but you can do it? Assets are super not designed to be imported at real time. Importing meaning taking a standardized format such as OBJ or PNG or any standardized format and pulling it into and converting it into Unreal's format. And you might think this is obvious, right? Doing a conversion of formats in real time is going to cause stuttering and hitching even worse than Unreal usually causes. But when we're talking real time or runtime, we aren't necessarily talking in the game. We might be talking at level load, right? If we're loading a level and we want to import assets from another place, you'd think that'd be a thing we could do. But Unreal isn't really designed to let you do that. Once again, you can do it, but then this gets much trickier than loading assets at runtime, where it's perfectly supported but not recommended, whereas, or loading individual assets at runtime where it's perfectly supported, not recommended, whereas importing assets at runtime is actively not supported. So what do I mean by it's not supported? Well, Unreal, to try and simplify the editor UI, I don't know if you guys can hear that thunder, that's terrifying. Anyway, Unreal, to kind of simplify the editor UI, has created this system where to import an asset, you have a asset factory that is designed to take in a file and turn it into an asset file. And the asset factory has a standardized interface that can be invoked from many places. So standardized C++ interface. Let's see if I can explain what that is. All right, I'm going to need the .h. Okay, so this is the standard, so this is the U factory interface. So an interface in programming literally means a series of functions that an inherited class is required to have. Now, there are some nice syntactic sugar in more modern languages for interfaces because they're honestly a better method of doing object-oriented programming than inheritance is typically, right? They're a form of inheritance, but they're inheritance without structure. So this is actions alone. Interfaces are actions alone, inheritance, no structure. And so if we scroll through this factory class, you can see that it's not quite an interface. They do have some structure, but it is mostly about these functions that you can override, right? So whenever you create a new object in Unreal, it uses a factory, right? It casts whatever class that you're using into a factory, and then it knows for a fact that there are certain functions available to that object, to that creation object. And so it can know, like if we go and load this random thing here, every single one of these implements factory create file. They're required to. If they don't implement factory create file, if we click on it, it would fail. And so that means that when you go to import an asset and I don't think I have any assets in here to import. You go to import something, it can determine what factory to use based on the file name, because the factory can also register itself to a file name, right? So it can call this function kind of wherever you are in the interface, and it doesn't have to know the specific implementation details of your factory. This is very useful, but it relies on the editor interface to implement itself. There's a bunch of things in UFactory that rely on the editor interface. And you cannot compile the editor interface into a game runtime. Not without basically completely rewriting the engine. I'm not quite sure why that decision was made. I can think of a few reasons. It might be to keep the binary down. It might be to prevent malicious redistribution of the editor, right? If you're rebranding Unreal as actually real and trying to redistribute the entire program, you can't do that because Unreal doesn't let you compile the editor into your game. So that's a bit of a problem, because if we want to import our Descent assets in real time, right, when we load the first level, we want to import the first level assets, then this factory system, as useful as it is in Unreal, is working against us, because we can't invoke a factory from runtime. There's a whole bunch of helpers that we can't invoke from runtime. It's really in the way. And additionally, if we have the editor modules in our build step, then we can't compile our game to runtime. So what we need to do is split these editor modules out. Right? So if we want to do what we're considering doing here with the trying to keep from distributing Descent assets, because that's illegal, I don't own Descent, and just pull in assets from the games people have already purchased, then what we're going to need to do is create some libraries here, a separation of concerns. There are 3 primary things we need to create. The first is our game, obviously, right? We need our game. And this is just going to be the core modules, right? These modules. Second, we need a library set that does not depend on any editor modules, but can be called by the game and things that do depend on editor modules to help us import things, to avoid code reuse. And the third is an editor module to help us import things into the editor for debugging purposes, right? If I have to launch my game every time, load a level, and see if I've got all the imports right, it's going to take forever to get the imports right, because it's a very long cycle debug process, right? Ideally, when I want to, the way I have it set up now and the way we want it set up is such that when we load up our little editor module here, we can just hit import textures and take a look at the texture we imported, right? Hey, that one looks good, but say we imported a second texture and, no, not that one. Grab this one. Oh, these are all blank. Shoot. Well, I'm not going to be able to show you a bad texture here because you fixed all the imports now, so there isn't a bad texture. Well, they're all blank or not bad. All right, but we import a second one and it's a bad texture. Then we need to be able to immediately see that it's a bad texture without having to load a whole level first and start a play session. We don't need that, but it's really, really helpful, right? So I can click on import textures, I can see something's bad, I can jump into my code, fix something, compile it, do a hot reload, and then jump in and click import textures again. That is a much, much faster iteration process than trying to start the game, load a level, go find the texture in that level, and see if it looks right? Because the other thing that finding a texture in a level is going to be subject to a perspective transformation. So we don't know if it looks exactly right necessarily. Here, we do know if it looks exactly right. Worse is things like levels, right? If we want to import a level and then see if it's right, we have to fly through the entire level to figure out if it's right. Whereas now I can just double click on the level and it'll load the level model here. Yeah, there we go. Load the level model here. And I can just fly around and take a look. Simple enough. Piece of cake. So we know we want to import into the editor for debugging purposes. we know we want to import into live for legal purposes. So to be able to do both of those without having to copy and paste code everywhere, we also know we want a small library with helper functions to load. Which means that we're going to have to split all this up into 3 separate libraries. We aren't going... Oh, well, we might get started on that tonight. But it is going to be a second. Yeah, we might get started on that a little bit tonight, but we're going to have to do a lot of thinking about where we want things to go and how we want things to go there. Because my code is not really designed to be splittable right now. The texture factory is kind of set up for splitting stuff. We have this that lets us split stuff, and right, but this part of it clearly needs some kind of helper function. And we also need to look into how to create libraries. Like, what is the minimum? We don't want to create a library that contains half the Unreal headers imported into it. So we need to look into that. Okay. So now that we've done a basic explanation of the organization part of Unreal, I'm going to kind of go over what I've done in the descent side of it, loading textures. And, well, we'll just go over the additional code I've written, both descent side and Unreal side. I guess we'll start with Unreal side. So, as I mentioned, I made a new class because it was very clear to me that I was running into walls. So, when I last left you, I had this, it's here somewhere. Thought it was here somewhere. No. Okay, that's very odd. There used to be a whole bunch of comments in here. I'll have to see if I can recover those. Oh, derp. I just have it collapsed. Okay, so last time we were here, I was working on the load textures, plural, function, and the save texture function. Right, so I had the save texture function that was kind of designed to avoid doing any Unreal Editor stuff, but I had recognized that I wasn't quite getting there, so I turned on Unreal Editor stuff to help me save. And it's all commented out now because it's old code and it doesn't work with the current code, and it'll mess stuff up. Like, there's a whole bunch of errors in it. And so the idea was that we were going to loop over all the textures and load them in and save them. And there were a couple problems with that. The first problem with that is there's a lot more textures than I thought they were. There is a ton of textures in Descent. I think upwards of 1,000. Well, we'd have to do some coding to find the exact number, but there's a lot. So this loop takes a long time a really long time. And the time it takes is not conducive to debugging, right? When we want to debug a texture or debug what we're doing, we want a fast iteration time, and having to wait, I think it was like 7 minutes every time we wanted to test if we were importing textures correctly, obviously wasn't going to fly. The other big thing that was happening is the textures weren't importing correctly. Like when we go to textures, you can kind of see the old thumbnails here of what the textures were importing like. Yeah, they were just a mess. You get like a first fourth that kind of looks like the right colors in the texture, but not in the right places. And then you get the rest of the 3/4 is just random gibberish. And figuring out what was wrong with that was clearly going to take a lot of time, because there was some really complex stuff going on behind the scenes here. So I stepped back and said, okay, let's figure out how to import one texture. So instead of doing load textures and save texture here, I went to load texture singular. I think it's load texture singular, not you. No, load bitmap and convert bitmap to texture. Okay. So yeah, I went away from load textures and just focused on load bitmap here. And with load bitmap, the idea was to pass off the bitmap to a texture factory, kind of sticking with Unreal conventions for now, because I was having a hard time getting things to save. So when you're having a hard time with something not in convention, move to conventions and work from there. So I switched to this texture factory that was going to be within conventions. It took me a little bit to figure out how to pass parameters into the factory, but I got there. And then that texture factory is going to call a few functions from the loader textures file. That's going to be load palette, load bitmap header, load bitmap, and convert bitmap to texture. All right, so 4 basic functions. And they're fairly descriptive here, right? So we first want to load the palettes because we need to convert. We need to decode the texture, and the palette is necessary to decode the texture. We need to load the bitmap header to figure out where the bitmap is in the descent file, and then we load the bitmap from the descent file. We convert it to a texture, and this is the raw bytes, and then we want to convert it to a texture. So it's going to decode the bitmap and then encode a new texture, and then we want to save the texture. We don't have to deal with any of the saving logic because we're using Unreal conventions. We can just return the texture. Great. So, as you'll notice that I mentioned parameters passing into this texture factory, because we aren't just going. The texture factory by default has a file name parameter that's expecting to get passed into it. Great. But we have additional things that we need to pass in to get a specific bitmap out, because the descent bitmaps are all squished into one place, right? They're all in one archive. Well, it's not really an archive file, but one large file. And that file does not contain the palette, right? So we need to pull the palette out, or so we need to pass a palette path in so we can get a palette for decoding, and we need to pass in the which bitmap we want to decode. Now, looking at this function, you'd initially think that obviously we want to pass that into the parms function, or the parms parameter. This is a kind of just pointer to an arbitrary string. It must be the kind of thing we want to pass in, except it's not, right? Because we won't be calling this function directly. Let's talk about how texture factories work, or how factories in general work. Okay, So a factory works as a as an object inside of an import task. So the UASA import task contains all of the things, all the functions, all of the stuff necessary to perform a import in standard Unreal conventions. And so to create, and by default, the import task is going to automatically figure out what factory it should be using. It might decide this based off the extension. It might decide this based off of the right-click menu, right? If you go in here and you create a new thing, it will choose the import task associated with the thing, except it won't be an import task. It'll be a new task, but you get the idea. Yeah, so however, it does provide us the option with specifying the factory. Like, we know the file format, we want you to use this factory for exactly situations like this, custom imports. So, but that means that the import task is deciding on the functions inside the factory. It's loading up this factory that you have, but it's figuring out whether it should be calling create file or create new or all the other potential things in the factory based off of the action you took in the editor. Whether you, if you're importing from a file, it's going to call create file. If you're right-clicking and doing new thing, it's going to call create new. And because it's calling it, how do you give it the parameters to provide to the create function, right? And some of that is obvious, right? The import task has parameters or has objects inside of it that correspond to the parameters inside the function you're calling. Great. So you can just set those parameters and away you go. However, some parameters aren't there, such as the parms parameter, right? The one that you think you're supposed to pass parms in with, it doesn't exist. Figuring out how to call it indirectly is very difficult. I wasn't able to figure that out. I'm not even certain if you're supposed to do that or not. So instead, what you do is you pass in options. Now, what are options? Options is a structure derived from UObject that has additional things that your bitmap or that your import could use, right? So there's a surprisingly small number of these in Unreal, but like FBX has a big options file that has all the things that you can set for importing FBX, because there's a whole bunch of little options there. And if you want to pass, special things to your factory imports, you need an options. So created a new options class, derived it from UObjects, and gave it 2 properties. Really that simple. It's incredibly overcomplicated for this specific thing, but sometimes Unreal's like that. So after we create the import task and we get all this stuff set, we then need to process the import task, right? And the processing the import task is basically just telling asset tools to go run it, right? We want to tell the asset tools to go run it, and then we want to get the object that the import task loaded and return that object. Great, no problems. Yeah. There's my load texture singular. Okay. So, well, that leaves us with the question, if we're not passing options as a parameter to our factory create file, how are we using it as a parameter? Like, how are we getting those options that we're trying to pass to it? And the answer is that every every factory, everything derived from the U factory, has an asset import task object on it. Like I said, it's not a pure interface, it's got a little bit of inheritance on it. So this asset import task object can read anything that we set on the asset import task that calls this factory. So we cast it to, we assume that we're using options provided by our D1 our texture import options object, because we're calling the D1 texture factory. If you're not providing that, that would be awkward. And we go ahead and assign the bitmap number. This can probably, this is probably fine. This probably needs to be fixed. In the palette path, if we don't have a palette path, we throw an error and we get out of here, we return. This, by the way, this is kind of my default error handling for Unreal right now, is we log error and then we return null pointer, and that basically means everything, all the object returns are pointers, which is actually probably best practice anyway. And after we return null pointer, the function is stopped, right? We cannot load a D1 texture without a palette path. Okay. So this, for reference, in case anyone is unaware, this is a ternary operator. This is just an if. It's an inline if. So if asset import task, so if this is not null, then we cast asset import task to our D1 texture import options. Otherwise, we return null pointer. Well, otherwise we assign null pointer to import options. Okay. Right, so that's basically how a factory works. You create an asset import task. You give it an options class that is derived from UObject that you create. Then you process that task by telling the asset tools to run it. And then that task is going to call the texture factory, which will pull the options that you've provided the task from the asset task import object that is a part of the factory. Okay, so now I've talked through all that. I want to point out a little quirk of weirdness here. Notably that the name of the destination name of the resulting file that you want to be made cannot be modified from factory create file. It creates the file, then calls this function to populate the file. Yeah. And so if you modify the name of the file here, when it then calls the function to, right, so this actually doesn't populate the file, it just returns the things to go in the file. When it calls the function to populate the file, it won't be able to find the file. And you'll just have an empty file with the wrong name, which is super annoying when you have an archive like file format, and like Descent does, and the name of the file that you need is inside the archive, right? All the bitmap names are inside the archive. And so I'm pointing it at an archive, telling it to go get a bitmap from the archive, and then I can't tell it the name to name the bitmap because I don't have it yet. This is where a library is useful, and where things are also a little silly, because I can call this function that I designed to be called inside the factory from outside the factory. I actually designed a second function to do this. And it's a second function that's just a light wrapper around the other function that I called from inside the factory. And that way I can get the bitmap that I want, the name of the bitmap, outside of a factory and pass it to the factory. Or rather pass it to the import task, which then passes it to the factory. Great. So let's go take a quick look at load header. All right, so we've got two different load bitmap header functions. They do more or less the same thing, except the first one makes and doesn't close its own header, or make its own file reader. I'm pretty certain there's an automatic cleanup here, right here, at the end, but we should at least call close. So, anyway, that's a mistake. All right, so it creates its own file reader and serializes kind of the header data from the file, and then is able to load the bitmap based off of that. Or load the bitmap header based off of that and return the header. And we're just loading the header, we're not loading the bitmap itself, but then we have the name for the bitmap to go into our actual load bitmap thing. The load header for loading the bitmap header has another weirdness in it. So we have it takes in a file reader, it assumes one's already open, where it needs to start, and the bitmap number it needs to use. So we create our new header because we are returning pointers here, so we need to create everything. We need to use the new keyword with things. And we head to where our start is, plus the header size times the bitmap num. So start is going to be the start of our list of headers. And then header size is going to be how long each header is, right? So we need to, if we want to skip over bitmaps, right, then that's how we do that. It should be noted here that if you're paying attention, this is a constant, but I already have a header here. Why am I not just doing size of header? Wouldn't this be great? Like, it's right there. It's the same thing, right? Except it's not the same thing. If you add up the size of the header, you get 17. 8 bytes for the name, 1 byte for the flags, 1 for the width, 1 for the height, 1 byte for the other flags, 1 byte for the average color, and 4 bytes for the offset, meaning where it starts where the actual bitmap starts in the file. But size of header typically returns 20, not 17. Why not? Why is that? Where do we get our extra 3? And the answer is padding. Most computers prefer integers to be aligned to the memory. Basically on a power of 2. Well, or not on a power of 2, on a power of 4. Yeah, on a power of 4. So if we add up everything before the bitmap 8, we get 13. 13 is not divisible by 4. Therefore, it cannot be on the memory alignment. So when we make this structure, the compiler will automatically shift the offset up by 3 to put it on 16 instead of 13, which is going to make the processor in our computer much happier and run much faster, and in some cases not crash. ARM computers, like the stuff in your phone and in the new Macs, will actually crash if the integers are not aligned. Sometimes, not always, but sometimes they'll crash when the integers are not aligned, which is really annoying to deal with. So, unfortunately, there's almost no way around this. C++ doesn't have, like, you can tell C++, or you can tell a compiler to not add any padding, but then, like I said, ARM computers will crash without padding, so that's not a good solution. And there's no way to kind of get an unpadded size. You can't do unpadded size of thing, right? It just, there's no operator for that. And creating an operator for that would be relatively complicated, because C and C++ don't have any reflection. It can't look at its own code. It just turns it into bytecode and assumes everything knows what everything's doing. So I can't have the thing go look at an unpadded size of by going and evaluating this structure. No, the only way to do an unpadded size of is to, at the time of creating this header, you actually write two headers. You write an unpadded version and a padded version. You take the size of the unpadded the unpadded version, save it in a variable, and then delete the unpadded version. And if you're thinking that sounds like compiler stuff, you'd be right. That is compiler stuff. The only way to do this is with preprocessor macros. And then I can't write this like struct header. I have to like do stupid things like new, struct and then stuff and then member and then stuff, right? And it's going to create use macros to expand that out into useful code. And a lot of, and so this is a little bit annoying because now we have to manually store the header size. And this manual, if something changes, can easily be unlinked, which is not good. It's really not good. And because there's padding, we also can't serialize these all at once. Okay, this code will compile and run just fine, right? If we ignore all the stuff below here, this will compile and run just fine, but this will compile just fine, but it'll give you runtime errors, because what's going to happen is you have your name and stuff and other stuff, like all your stuff, and then you get to the 13th bit, and you start putting your integer in there. So we'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? And say we have an integer that's 4 bytes long. We'll just do 4 decimals here for simplicity. We'll have an integer 0, 1, 1, 4. That looks great, except that's not right, because remember, our header is 20 bytes long. So this is 17 bytes. There's now 3 bytes after this. And when we go to read our integer from this, it doesn't read 0114. It reads 4000, 4000. Which is not only confusing, but wrong. Very wrong. So we have to serialize everything individually, which is another manual thing that we can now mess up. So it's not even good enough to create those macros I talked about that enabled us to calculate the unpadded size and then save that into a variable somewhere and stuff like that. No. You also have to somehow calculate what the offset difference is. So you would have to be able to also have a function. So we'd serialize into a temp header, and then we would go ahead and do header equals temp header dot add padding, something like that function. Something like that, where this add padding function would know what the difference between an unpadded header and a padded header is and shift the bits accordingly. That's a fairly complicated function to generate on the fly. Rust macros could do it, and I think macros in a few other languages could do it. On the one hand, I really want that. On the other hand, that is complicated. That is very complicated to put into a game here. So we have to, all that to say, we have to serialize each of the things in the header individually, because otherwise things go wrong. Okay. So we load the bitmap header twice, and then the next thing to do is load the bitmap. Load the bitmap. Okay. This is fairly straightforward. So the bitmap does not have to correspond to any sort of size constraints in descent, right? We are not referencing any of the descent. We're not directly referencing the bitmap bytes in the bitmap file bytes from the bitmap structure. So this is can be an arbitrary structure that can be whatever we want. And I've taken advantage of that to switch out our data from a pointer to a specific, to an array, right? Previously, the way descent handles this is actually really clever, but really annoying to deal with. And that is, there is one giant array where all the bitmap data goes, and then each bitmap contains a pointer to a place in that array, which is quite clever, but like I said, horrible to deal with. So we've got a special array in the bitmap, or we've got an Unreal array in the bitmap. We're using Unreal's types here. We're using fstring. And this just really enables us to, we're using an initializer, and it just enables us to do things simpler because we don't have to comply to the descent bitmap structure when we're not directly referencing the structure that's in the file. Because the header is what's referencing the structure that's in the file, not the bitmap. Okay. So what we're doing here is we're heading to our start position plus the offset in the header. Our start position is a little bit complicated. We can blame that on descent. Um, and then, yeah, then the header offset is pretty straightforward. It's just an offset from the start position. So this is where things get a little weird. We need to, so the functions in descent that I'm referencing explicitly expect that the size, so the bitmap has at the front of it in the file the expected size of the bitmap, or the compressed size of the bitmap rather. And descent expects that compressed size to be a part integer to be a part of the bitmap data, which is a little bit weird because the rest of the data is not integers. It's right. Well, they are integers, but the size is a 32-bit integer, and everything else is an 8-bit integer. And so it's a little bit weird to have this random different type in the front of the data array, but it is expected by all the functions that we're using. We want to keep the functions as close as possible to the descent functions to avoid import errors. Like, it's just going to be easier that way. And so we do a little bit of pointer arithmetic here to convince the convince the compiler that our 32-bit int size is an 8-bit int, and then read 32 bits from an 8-bit int into our array. That's what we're doing here. We are intentionally overreading an 8-bit int that isn't actually an 8-bit int. It's actually a 32-bit int. So yeah, that's yuck, but it works, and it's cleaner than dropping a for loop in there. It's a little bit scarier because C++ doesn't have a lot of safety mechanisms for what we're doing here, because there aren't good safety mechanisms for what we're doing here, but that's fine. And then we want our data size is going to be the expected size minus, let's actually just do and I actually want to go ahead and change all of these to size of z size. And I'll just make things more flexible in the future, right? So now we just have to change this one thing, and ta-da, it all changes. We might, like, so for example, if this z size changes in descent 2, we can kind of split this all out into a function and just change the one thing, and that'll be pretty easy. Okay. So our data size is going to be the size of our initial int less than the data size listed in the file. And then this is just a little debug for me to make sure I was writing z size correctly. And then this is if our bitmap is not encoded. I think almost all of them are, though. Okay. So what we do is we create a temporary array with the size of data size, and then we serialize directly into the array, and then we append that onto our bitmap data array. Pretty straightforward. Nothing fancy there. Yeah. Great. And when we're done, we return a new bitmap. So we've got a nice compressed bitmap. And with that nice compressed bitmap, we now need to convert it to a texture. So we need to uncompress the bitmap and write a texture. So our convert to bitmap function is first going to check if we have an encoded bitmap, and if we do, we want to decode the bitmap. Notably, this is actually a bit of a malformed function. This should be like a constant pointer, probably. Pass by reference is probably fine, but this should be constant. We should not be adjusting this. I should be making a new thing to drop data into. And so our decode is where all the stuff from descent is, and things get kind of interesting there. Yeah, let me show you that real quick. Okay. So the decode is largely pulled from this this decode function, which calls this assembly decode function, which is a nightmare. Because it's an assembly, it's actually not that complicated. But I coded this function up and dropped it into the Unreal side, but I was not getting textures. I was getting very short decodes. So this thing ends when the it ends when the read in byte is equal to 244. That's a little confusing, but that's what it does. Sorry. It's 244? It's not 244. 224. Sorry, 224. Because 224 plus 31 is 255, which is the maximum an 8-byte integer can represent. So at 224, if it reads a byte that is 224, it exits. And that's the only exit. This is a while true loop that exits if it reads a byte that's 224. That's surprising in several ways. Most notably, that if you run this function, you're expecting to get a full texture back, or I was expecting to get a full texture back, and it returned like on something that I know is legitimate. It returned like 50-ish, a little less than 50, or a little more than 50 because I wasn't calling it right. 50. It returned about 100 bytes. That was it. I was like, this is expected to be several thousand bytes. Why are we returning just 100 bytes? And so what's going on here is that I was calling the function incorrectly. Like, I went through a lot of work playing with this function, trying to get it working right. Eventually, I figured I was not having any issues with the function itself. I needed to start looking elsewhere. So I got it exactly the same as this. Well, not exactly the same, but all the functionality is exactly the same. And started looking elsewhere. Started looking for where this function was called. And I found out that basically the only place it's called is right here in this decode row function. Tells you something, doesn't it? That's not decoding a texture, that's decoding a row within a texture. This is part of the rendering pipeline for Descent. And I was a little confused as to how do I decode the whole texture instead of just a part of a texture? And it turns out you just input from, you just tell it to stop at you just input the whole texture, the height of the texture right here into this decode row function. That's all you do. And while I was looking at this decode row function, I noticed, or while I was rewriting this decode row function, I noticed that there was this 4 in here. What's the 4 for? Well, if you think about the only other thing that we know, or the main thing that we know is 4 in our texture data, is the initial size, right? That we read in. This is why it's important to read in that initial size, because all of the Descent functions, it kind of expect it to be there. And so that's when I had to modify my functions to read in that initial size, because I wasn't reading in that initial size. I was reading that initial size to a separate variable initially. I wasn't putting it in the array. And that was the primary thing that was causing my bitmaps to be all messed up, like we were showing earlier, all messed up into this mess. Well, that was actually what was causing it to be like super skewed sideways like that. It wasn't what was causing the rest of the rainbow. The rest of the rainbow was being caused down here. When after we got all that texture processed and outputted, we were copying into our new texture. The function looked like this. Something like this, not quite like this. We were allocating the bitmap height times bitmap width times 4, because we were using F color to represent our texture. And F color is 4 bytes. Yeah, 4 bytes. But we were copying the size of the texture into it. Not the size of the texture, sorry. The length of the texture. The length of the texture array. And the length of the texture array is obviously going to be short. Right? Because the length of the texture array doesn't include the size of the elements in the array. So we made some adjustments. This is actually much safer now because we're using the same variable for allocation and copying. Same size variable for allocation and copy. And now we're importing whole textures. So we can let me close this. We can choose which texture we want to import. Let's just import the first one. I need to make this into an option so it's a little easier to edit. Go ahead and hit import texture and head to D1 textures, and we got robot. I was actually expecting it to be robot 10. Oh, no, right, because robot 10 is 0. Robot 01, which is just a giant eye. That actually makes a ton of sense. Now I want to import 0. Okay, this is our first robot texture. It's kind of just a fun pattern. And then our second robot texture is an eye. And I'm wondering if these textures, I kind of all go, if one robot takes multiple textures. And a cool thing we could do is we could add a loop here. Yeah, just a little for loop here. And we're going to just do the first index is 0 and the last index is 10. And index over here to bitmap number. And yeah, just like that. And save and compile. And now we can import 0 through 10. Just like that, we've got robots 0 through 10 imported. Interesting that robot textures 0 through 10 imported. Robot 0 appears to be a claw robot. You know, 2 claw robots in Descent 1 looks like. That's what Robot 0 looks like. Sweet. Now for my purposes at the moment, I'm going to go ahead and just import. I want to import all the textures. Oops. That's going to take a little bit, so that's going to kind of be the end of the string. I'll set up importing all of the textures, and we'll go from there. 1,555 textures. But I, of course, want to set it to one lower than that because this is an index, not a number, because we're starting from 0. There we go. We're going to save this, we're going to compile this, and that's going to be on the stream. I'm going to hit the start import button. We're going to be done for tonight. Just kind of wanted to share everyone where I've gotten and kind of talk about the organization structure of Unreal. And I won't be streaming tomorrow or the day after, but I think I want to get back to streaming regularly on Monday, when we'll probably start working on organizing all these files then. Have a wonderful night, everyone. I will see you later.